Welcome back to Made Up of Wires. We're decompiling Castlevania Symphony of the Night. If you're not familiar with the decompilation project, you can go to soten.z.dev and learn more about what we're doing there. We've been looking at Medusa the past couple days. We have one function left with Medusa, and I think we'll keep working on that. When we're decompiling Castlevania Symphony of the Night, or any game for that matter, I actually brought a stack of games out and probably misplaced it. Oh, they're down here. When we're decompiling, what we're doing is trying to reproduce code, or trying to create code that will compile to exactly the same thing as what was shipped on the disk. And this project was already pretty well along and well established while I was when I found it a few months ago. And I've been contributing ever since. And many of the main devs on this project have also started other decomps. There is, I know, a Mega Man decomp for the PlayStation and some other work there. And I've been thinking about doing something similar, and I might every once in a while dedicate a show to something slightly different if I find it interesting and if I end up doing anything with it. For Castlevania Symphony of the Night, though, you can look at soten.z.dev and find a link to GitHub where you'll see the code that we've uploaded. So last week we spent a bit of time working on Medusa, and all of that code was merged yesterday, with the exception of the function that we finished off yesterday. And then there's the one function that is remaining there. The Medusa overlay still isn't in on the web page, and I haven't looked into why that is. It may be something in the doc branch or the docs branch, but I haven't looked at that. It's not something that I admin at all, so it's not something I'm as familiar with. There's a link to the Discord server as well, and we're talking about all kinds of things related to Symphony of the Night there and tooling. And yesterday I mentioned that I was working on some tooling for finding functions, and I finished off some work with that. So I found a tool called bgrep. Let me see if I can find a GitHub link to that. And actually, Josh mentioned a tool as well, which I'll try to find what he was mentioning too. So bgrep is a tool that works a lot like grep, except you're able to pass byte patterns in, and it does support relatively limited masking. The issue that I had with the tool is that the pattern and the mask all needed to come as command line arguments, and what I wanted to use the tool for was finding duplicate functions. And so I did a bunch of work so that you could take a function binary in as an argument, the path to that, as well as a mask for that binary, and that seems to work exceedingly well and is super fast. And so I need to spend some time making the mask program, and then try to get that integrated, I think, into make config, which should speed that up considerably. And yeah, we'll see how that goes. Morning, Arkham. Fortnite decomp. I've attempted to play Fortnite several times, and I can't. I don't get it. If I'm fighting for my life in a battle royale, why would I want to stop and build something? I don't know. I tried it when it first came out, and maybe a handful of times since then. All right, let's go to our function and look at where we were. We're not too far in this function yet, so quite a bit more work to do, but not not a terrible amount of stuff here. I would like to point out, if you haven't seen it, I'll post a link. Let me see if I can grab a link real quick. I enjoy video game soundtracks quite a bit, and Symphony of the Night has a wonderful soundtrack. I'll post a link. It is an affiliate link, and I will get a penny maybe if you if you click it and buy something. But the what I thought was an out-of-print Symphony of the Night soundtrack is available on Amazon from Amazon.com, and it seems to be, as far as I can tell, an original. I don't know if they have reprinted it recently, but it is an older release that is available. If you look at any of the tracking sites, several years ago this was like $50, and now it's down at $23. So pretty good for a soundtrack. Okay, so this is the last function, as I mentioned, remaining. I haven't looked at what it does too closely, too blind and focused on decompiling. I hope the school accepted your kid back entropy gravity well. Without too much fuss, anyway. So we were looking at these. Let's see. I'm just gonna kind of review this real quickly and see where we are and see if there's anything super obvious. So this looks like a for loop here. E is 14. I will try to keep an eye on some of this along the way. This does look very similar to some of the other code here. So one thing I'm noticing is this add 0, or this set to 0, and this reference to self appear to be out of order. And I almost wonder if, let's see where this is being set. I almost wonder if this is being multiplied. It doesn't look like it though. The negative offset here tells me that it's actually taking a address slightly after where we would normally think that the entity starts, so it has to backtrack to get this value. That probably is related to something that's going on up here. I'm going to ignore that for now and just kind of continue down and try to just see how things shake out as other things get cleaned up. Here we're taking a temporary variable. There's some things that could go wrong here, but we'll see what happens. So when you're reading a variable from a structure and then assigning a value to a pointer to a structure or a field within that structure, it's possible that the compiler can't determine if this is aliasing or not. And aliasing is we have two names for the same address. I would think in this case, though, that it should be able to figure that out. But what is being generated indicates otherwise. This is almost the fact that this happens twice is odd. So this is the same instruction generated 2 times. Oh, because one is a jump. So let's try to duplicate that. So when we have a jump and link in this case, or a branch, we always execute the instruction immediately afterwards. So for this call to cosine, or R cosine, we are also executing this immediately afterwards, and that's taking this S0 value and putting it into the A0 register, which is the argument register. And I'm going to move this back. Oh, things are going slow today. So this does look like it is being pulled out as a variable. I'm going to rename that temp A0 angle. I don't know if this one is necessary. No. Okay. So it does look like it was pulled out into a variable. Let's see if I can find temp A0 in this mess. Or S0, I'm sorry. There is this interesting instruction here. So we're taking that angle value and putting it into another register, and then it looks like we're storing that on line 106. Well, this is going incredibly slow. If this keeps going slow, I'll switch over to mapping some of the shared code in Medusa. I'm going to do a good job of making sure that I found all these. So our this came from the decompiler, but it looks like this actually falls through, which is a little odd. That oh, we still have one more S0, 106. No, yeah, it's just going very slowly. All right, so we have a wrong register. It does make me think that maybe this is all just going to this, though. And once we get all of the references, maybe that'll work. But no. Yeah, I think what's happening here is we're writing to velocity x and velocity y, and the optimizer ultimately says I can't prove that these aren't going to overlap, or that sine and cosine aren't going to do something with that pointer either. So I'll worry about the register later. The other thing that I mentioned yesterday that we're eventually going to have to do is figure out what the extension structure looks like for this. There are several cases where it was not able to figure out what field it should use, and eventually we'll have to figure that out and probably define a new struct. I do have to get a new context because the context has moved faster than I have. Yeah, this went really slow. Okay, that cleaned up the register. So using the same variable down here seemed to be enough. So here we're going to be decrementing this value and then effectively testing it against 0. The shift is unnecessary. That is being done due to the way the compiler or the decompiler thinks these instructions should be written, basically based on casting. Down here on line 118, which is 117 here, hex 80 is flag dead. Right? And we can increment this. I thought it was flag dead. I can't tell if the compiler is going really slow. I do see that I'm dropping frames, so it's possibly my internet connection. My bad internet is back to haunt me. Well, they did do some work to fix the internet here last week. They were not able to resolve everything completely, and so occasionally we still get drops. I really thought this was flag dead. I don't see anything too terribly awful, though. All right, let's keep going and see what else we can find. We have a bunch of... we'll look at the context and see. Oh, flag dead is 100. I was wrong. It's not draw menu. I haven't caught up on spell flag known. Could that be it? Oh, I doubt it's that. Element poison? Do you get poisoned by Medusa? I know you get stoned. I'm not sure. I'll come back to that. So then on line 128, it looks like this may be inverted. So let's try to resolve some of this. So these, I haven't gone through and switched these references to structs yet. That will help a little bit in some places, but I don't think everywhere. I'm going to create X and Y variables for these, and those will probably be used elsewhere. So this one was, that's unique enough. So here, say -64. So this probably is going to get inverted. So greater than or equal to, and greater than or equal to, and less than, and less than. Then we'll do this. That's the only reason I. Oh no, we are getting that. Never mind. It looks like here is where the missing jump is. Let's see if that works. Oh, this is slow. So here we're loading. It's wanting to load signed values from each of these, but we're loading unsigned. These are both fixed 32, which it's a 32-bit value. The fields in it are yeah, they are signed. So why are we generating unsigned instructions? X and Y created as signed. Okay, that seems to be fine. Odd, I think that they'd be loaded as unsigned. I'm trying to think of what the advantage is. There's so when you're, the nice thing about 2's complement for negative values is that the mathematical operations work the same regardless of whether or not the number is signed or unsigned. So the CPU can kind of be oblivious to the type when it's doing those operations. And so possibly that's why these were being loaded as unsigned values. Maybe that's a cheaper instruction. When these need to be upgraded to a 32-bit number, however, you have to do the sign extension from 16-bit to 32-bit, which means taking that bit in the 16th position, depending on the highest bit, the sign bit, and then populating the upper 16 bits with that value, whatever it is. I'm trying to teach my son some of this low-level programming stuff, and we were going over this, and he's kind of a math genius, more so than I ever was, and he's just like, yeah, okay, I get it. I don't know if he does or not, but he claims to. All right, so we have some register issues. I'm not too concerned with that. And then I thought doing this return here. Oh, it's here. This is where the return should be. Yeah, that worked out. Still register issues, but I'm not going to worry about those. So here's one of the cases where we're running into issues with the extension. This was misnamed when I did another replacement. But let's see if we can find where that's being used. I don't see it actually being used anywhere, which is troubling. We could go back and look at the decomp and see. If you're watching on YouTube, you're going to get a better presentation than the Twitch viewers are right now. I'm just checking things on the computer to see if there's anything I can do to fix things locally. All right, so I'm looking at the decomp to see what this reference was being used for, because it looks like I obliterated it at some point by accident, and it looks like it's supposed to be this var S5 _2. I don't even see where that is anymore. Oh, it became this up here, which is why it's not there anymore. Yeah, this doesn't seem quite right. So what is happening here, looking at what the original decomp was doing versus what I have here, it's grabbing a reference out of the extension and then setting some properties on it. This may be a pointer to another value. Let's look at 3C and see what might be there. Oh, this stub is generic. Offset 3C in the stub would be the first. So this is actually not part of this stub. It's the first element after. So it's something that's going to be in the 7C position. So we want to find something with a pointer. Yeah, and this seems common that it would be a primitive. I held my tongue, but I do believe that's used in a couple different places. So that gives us a hint that it is most likely a primitive in that first spot. So let's grab that. And this reference in the second one is, it just knows that the compiler knows that it has to load this other address. And it's kind of preemptively doing that because it's going to be manipulated in this loop, 13 times? So we have a prim variable already. What I think we'll do is start our extension. And start filling those out as we come across them. So I'm going to create a type def here. One of the things that you can do in C, so C, you need to pre-declare basically everything that you're going to use, except for, in these older versions of C, a function if you're going to call it. But usually it's pretty good. It's good practice to do that. I'm going to pre-declare this struct. We'll call it Medusa, even though I'm not sure that this is Medusa. This could be like the laser. This could be any of the other effects in the game. I'm not positive what this is yet. I'll just call it Medusa for now. So I can pre-declare this struct and say, hey, compiler, there will be a struct at some point. And even use it in this struct, but I've not said what the size of it is, or sorry, in this union. I've not said what the size of it is, what the actual structure is, and then I can go and define it later, which is an odd concept in modern programming languages. Declaring something and defining them are, in modern programming languages, those are basically the same thing, but in C, those are different operations. In modern languages, we usually call those interfaces. So then down here, I can take my reference, and I think just doing it right here should be fine. I say all these things and then fail spectacularly. On through a 6, it's not happy. Can I just say struct Medusa? Let's try that. Okay, yep, that worked. And I probably don't need this anymore. Yeah, that's fine. Oh, it is giving me an error because there is an incomplete type. And that's because I don't have a semicolon. There we go. I always forget the semicolon after struct definitions. That's an odd quirk as well of C and C++. I should say, it's not a quirk. More modern languages got rid of that. Objective-C, Java, things like that. When you're defining types, you don't need that trailing semicolon, but for some reason in C and C++ you do. Well, I shouldn't say some reason. These are statements, and that's why you need it. Okay. Of course, I didn't have any of that on screen, so you didn't see any of that. I perfectly defined that structure, and it looks like this. It has one field. It is a primitive. Nothing went wrong, and the compiler did beautifully. It was perfect. The most beautiful compilation I've ever seen. All right, so we have this prim, and these are all going to be using that. It does look like we are, instead of going forward through the primitives, we are going backwards. And I do need to see whether or not we're mutating the value here. And this will be a for loop. Okay, so I have these errors, obviously. But a primitive doesn't have, it's right, the primitive doesn't have position X. What are we looking at? We're looking at offset 10 on this, and a direct access to this here. Oh, and this is the hint. Dumb of me. We are looking at a entity pointer, not a primitive pointer. Hey, Tux can play. I don't really talk about it on the show, but the show is made up of wires. I'm just the host. Anonymous host. I didn't think about that really before starting all this. It was just kind of a flight of fancy. All right, let's see what we can see. Okay, so here's a couple interesting things. The offset we're loading is not far enough back. Um, 139. A lot of this is out of order. Making a little tough to follow. So kind of walking through, and if you ever look at, if you've ever done debugging of optimized code and you see the line that you're executing kind of move up and down, this is what's happening here. The optimizers come through and said, I'm going to do some of these loads, I'm going to do them first because those values never change and I can store them in registers. And then I'm going to do some of the other things that may or may not be more expensive. And it's just trying to save time and save resources. But by doing so, it can be difficult to follow at times. So we have this play positional effects. That's actually happening way up here. Oh, excuse me. I'm not compiling, so I'm not giving you the right offsets. Okay, so we don't have a pos x and a pos y in our primitive, which is not a primitive, it's an entity. Yeah. Yeah, that's the show name. When this one doesn't seem necessary anymore. My usual online alias is a very personal identifier and not very unique. So I try not to use it too much on like casual platforms. Professionally, I might, but it never occurred to me that having a show name and then using a different alias, like in Discord, I'm Sulaco on Discord, might be confusing. But you'll learn as you do these things. So I'm looking at these. Yeah, so we need to go to entity and see what these offsets are. And it's possible that this is not an entity either. It's possible it's something else. Yeah, entity pos x and pos y. I see. That was my issue, is that the entity does. I was just using the wrong variable. So we're getting very different offsets still. And it's a little curious. Also, though, this 7C, this is the offset of where the extension is in an entity. Which makes me think that this is the misnamed, yeah. This misnamed value here. And where's our error? Our error is in this type name. Oh, it's still upset with this. Drat. I thought that this would work. Often you can separate the struct from the entity. Or sorry, you can separate the struct from where it's being used, like doing this. There's a forward declaration of entity. But this is giving me problems. Okay, so, sorry, I don't need to do any of that. Let's go back here. So, no member name prim. That's because I renamed it entity. No, I didn't. What did I name it next? All right, so let's see how that works out now, finally. So there's still some issues here where the extension, this offset isn't being calculated like I would expect. This looks as if it's not starting with the field. It's starting with like a -1. However, the offset of that is BC, but we're only getting an offset of BA. And then when we come down here, our offsets are also off by some value. I would expect it to be off by 4, but it's off by -4. Or sorry, -8. Off by -8, but it's off. So maybe these are being loaded backwards. I don't know. There's something funny going on there with the way that the offset is being calculated. Oh, and maybe this then is just looking at the previous one. Not quite. I'm gonna have to go back through and look at that a little closer. Maybe, yeah, it's not. So now we have it down to a B6 versus BA, which is interesting as well, because the size of this structure is B C. And actually, this is out of order as well. I think I'll come back to that, and there's some complexity there. This we should be. So we're going into this stub, and it's at the correct offset, but it's not very useful to just be using data in a stub. So let's look at the entities there. So when we're using when we're indexing into this stub, basically it's just there. So the extension is up to 3C in size. So 3C is 60 bytes. We have 60 bytes that we can use. And the stub is just 60 bytes of random data. So we're at offset C, which is 12 bytes in. It starts at 7C. So 7DE. So we're at 8E. We're looking for a field at 8E. And 8E looks like it's mostly unknown 8E. There's some... Succubus has a Y offset there. But what we need to do is start filling out some of these other fields. So I'm just gonna take Succubus because that might be a. Actually, I'm gonna look for the Gaibon. GS props. SG props. Somebody props. GS props. I'm going to see here. So my theory last week was that a lot of the Medusa stuff and Gaibon and Slagra use a very similar entity layout, and that has been true. With Gaibon and Slagra, though, we don't have... they're not using that first 4 bytes for anything. But that doesn't mean we can't redefine that. So I'm going to grab these and use those fields. And then, so 12 bytes would be 8, what did I say, 8E? Oh, there's just padding there, though. So we'll try this Y offset from Succubus and see if that ends up making sense. Oh no, we already have that. And are we getting the same? Nope, I'm off by 4. And we just have padding at 8E. Let's see if that could be our X offset. So I am not confident in that. Oh, we're further back even. Okay. So let's see how many of these we can get cleaned up. So this virus 4.4 is, this is another one of those cases. It's defined very much out of order, but it appears to just be our index variable here. B is 11. So anywhere that we have that S4 we can replace with I now. And get rid of that variable. Temp A2 looks like it's a variation on Y. It's only used to set this offset 86. This may be the next attack. So we'll have to look at that as well. I'm going to take a brief pause, and you can enjoy the music, but I'll be right back. All right, we're back. We're still decompiling. Excuse my absence. So what I'm looking at here is what could be at offset 86. The structure that the decompiler chose was unknown. I see that Succubus uses, it's called Next Attack for Succubus. I'm going to go back to the Gaibon. I'm looking at that off screen. For Gaibon, it's near death. When Slagra loses its spear, or Gaibon is in rage mode. Let's see if there's anything else that we have here. 84 is attack mode. However, that's getting set to the X position high. Yeah, I don't think either of these things are necessarily correct. So I'm just going to call him unknown 84. Let's go back though and look and see what type that is. So we can tell the type. One hint is looking at what the decompiler chose for its casts. The other one is looking at what the instructions are. So here we're loading unsigned 16-bit values, and then they need to be stored somewhere. So where are these? Where is V1 being stored? So it's being stored back to this offset 84. So that it's pretty certain that that offset 84 is a 16-bit. Is it signed 16 or unsigned 16? I don't know yet. So here we will switch this to Medusa. This can be a little tricky going through and try to figure out, oh, interesting. This is a miss. We can try to set X here. Yeah, that's starting to pull some of this together. And so most likely then this is a Y value. So these look like XY offsets. And I think later on that'll help us figure this out. So here's also our hint that these are X and Y. So we'll have to rename these, but we can keep these names for now. I also still don't know that this is Medusa necessarily. So yesterday we did spend some time trying to figure out what each of these functions was in the Medusa overlay. But what happened was effectively all of them are called for every frame of that fight. And so that quickly overwhelms any attempt at trying to differentiate those functions. Oh, a bunch of these that need to be figured out. when the decompiler comes through, basically it's oh, I probably missed this one from before. It's every time that there's a change in register, it's going to try to make an assignment, even though that's usually not necessary. Yeah, we still have quite a mess here. I'm gonna look down here a little bit and see what we have. The stuff up here may or may not be better solved with the PSP version. Sometimes when you're decompiling, you get relatively myopic, and it can be hard to see the forest for the trees. So this is interesting as well. So here, this was being pulled out as next step, but it looks like that this is a set of XY coordinates. Possibly several, and we can. How can we look at this? This is an active entity, so it's a little more difficult to look at it directly because we don't have an assembly dump. We'd have to go through and dump or look at the memory in the debugger instead. I'm going to save this off. We're a little closer, but not terribly close. And I'm going to let's find a unique value and see if we can find the PSP version. I will get rid of these. Just make sure we don't need those. And do we need these? Nope. All right. So let's find the PSP version. Like I said, I'm going to look for a unique value that's relatively specific to this. So like this 6C is not a value that I see very often. The color lookup tables probably are the same. So 194 might be a safe value to look for. We just want something that's not going to show up in too many functions. I do have to look at some of the tools that Biz Murphy's been creating. He has made lots of nice tools for inspecting the overlays and looking at things like sprites and other things like that I haven't taken the time to look at. So we're looking at the US boss RBO3. Sorry, not US. We're looking at PSP EU. My script extracts it to stage. So we have a couple. It should be one of these earlier ones, I would think. Let's look at this. Let's see if we have a relatively similar structure here. So a large stack. A stack is basically the same size, which is promising. Let's find one more unique value. We have this flag that's using a relatively large constant. So there should be outbox 80. And there is. So this, yeah, this looks like the same thing. I'm pretty happy with that. So we're going to cat this file. And we'll create a new scratch. For PSP. And one thing I haven't spent time doing either is looking to see if anybody else has decompiled this function, which is usually a courteous thing to do. The way that these entity extensions work it's very smart. The one thing that I don't know, though, and maybe there's a better way to figure out how to do this. The way that we have it set up, we have this extension. We know that these last 60 bytes of the entity struct are used however that particular entity wants to use it. What I'm not sure of, though, is okay, so this is interesting. So 8.8. Oh, it's just the wrong type of this variable. That's fine. Having these structures in a shared header would require all of the entities be known then in that header at compile time. And the way that all of the overlays are written, I don't know that that would have been the case. They seem more decoupled than that. Maybe not. I don't know. So 142. We're looking for this next 3 variable. Well, that gives us a host of new issues. That's because the compiler picked it up at the wrong time. Var fp. It's odd that MatureWorks is so strict about that. Oy, oy, oy. This is terrible. So either I have the wrong function completely, or we're just really off. Looks like I have the wrong function. Alright, that's okay. That happens. So we need to find another one that is about that same size. Let's do this. I'm gonna do grep L. And then I'm going to run this through xargs and just get a size for each of these. Oh, they're all about the same size. Let's find what our original function was. So what I'm trying to do is find the PSP equivalent to this PlayStation version of the function. The PSP versions are compiled with a different compiler with no optimizations, and they're usually a bit bigger, about 50% or so bigger. So we're looking for something around 30K that looks like this one here. Let's see if we can find anything that can convince us of that a little more. The stack is much smaller, which is somewhat surprising if they are the same. So I was looking, what made me think that it was the other one was some flags that were being loaded. Particularly this one here. If we look at the instruction for that, 65. So it's just loading the upper part of this byte, or this register. I thought that it looked a lot like this. So this is loading upper immediate, and then it's shifting over hex 80,000, which is the same as loading the upper 16 with hex 80. The reason that the value isn't just loaded directly is because when you're loading immediate values, you only have 16 bits of space in the instruction to store an immediate value. So if you're loading a 32-bit value, you have to do it in 2 instructions. And it's ORing these and then storing them back. So that, let's try this one. Oh, we did get a partial decompile. So we have 2 cases, or sorry, up to case 2. Let's see if that matches what we have here. Yes. The way that the original was decompiled basically was a big go-to to this, maybe not that loop, yeah, this block. So basically every case, when it terminated, jumps here, but that gets pulled out then eventually. The way that this is, I'm kind of debating whether or not this is cleaner than what we have. It's decompiling on its own without any additional jump table, which is convenient as well. So we can get a decompile there in the future if we need to. Context. I have no context. That's troubling. And so we'll need to get that Medusa struct definition into the context. And then fix those types again. I wonder what type the MetroWorks compiler, or why a sign char and a char star are not the same. 45 is much better than 1%. Not great, but that's what the PSP does. So a lot of register issues, just kind of going from top to bottom and seeing what the issues might be. 53. Somewhat surprised that this is so different. I'm trying to figure out whether or not this assignment should be happening earlier. So I need something that is going to be loading, storing offset 64. And it is happening earlier. But not that early. And now we're done to this loop. I will continue on this later. Sometimes when you get messy decomps, let's look at this one real fast and see if this can be cleaned up. So the first thing I see here is that we're basically doing a assignment to RGB all at once. And we can possibly just assign this directly. Some of the values are different. You get that sometimes with magic values that the compiler produces. Just trying to match this. Yeah, this one should be up higher. I might not be able to get that right now either. Yeah, I think we'll come back to this. So let's look at one more thing before I sign off. One of the things that needs to be done with overlays as they're brought in, and this is kind of the tooling that I'm trying to work on offline as well, is we have a lot of shared code, and that shared code needs to be mapped in. And as we map it in, we get closer and closer to getting a full match for that overlay. So we're looking at the boss RBO3, which is Medusa, and let's look for files that are still including assembly. And that's most of them. And things like create entity or SD common, we can use common files for those, and many of them can be mapped pretty quickly. So I'm going to look at US boss RBO3, the splat config here. So we have all of our segments that we've split this file into. If I look at the Maria clock, Maria clock tower cutscene, clock room cutscene, excuse me, we can see a lot of the same offsets, and so there's things like E life up. We already have the RO data segment mapped, and we know where the code is supposed to be. What we're missing is just including that header file in the right place. So let's open that up. We're going to go boss RBO3 E life up, and if we look at the Maria version of that, all we're doing is including this other header file. And so we can do that here. And when we build, we find some things that we need to find that we don't have yet. And because we just extracted the assembly, or we have the assembly extracted, we can do our best to guess what those values are by looking at, we're going to look at the assembly from this overlay, RBO3, non-matching, E life up, and we'll just choose this one. I'm not sure if this is the right one to be looking at, but we'll compare it to the source for stage E life up. And what this was telling us was that we don't have prize drop defined, equipment item drop, or the relic orb. And this is actually going to help us quite a bit because we can, if we can figure out where these values are, this will give us new entity IDs that we can map in the header file. So what I want to do is see if playable character is here. It is. That's good. I'm going to unwrap that so we can read it a little better. And then here is our reference to entity prize drop. And so what we need to figure out between those two is which one of these is going to be the entity ID. And I think it might be this hex 17, which is 23. So when we OR something, or an immediate value with 0, as opposed to loading an immediate value. Why this is done, I'm not quite sure why you would do this as opposed to loading an immediate value. It's possible that the result of this is a 32-bit value, whereas load upper immediate is not. So we're loading this value here in v1, and then we're storing it off in a bunch of places. We're storing it twice into why are we doing that? Oh, that's params. Sorry. So we're a little bit after params. Here we have hex value 10, 16. That is another possibility. Let's look at Maria and see what her price drop is. Her price drop is 3. And these follow a very similar order. So I'm going to assume that ours is 3 as well. I screwed this up a little bit, but I will. I don't want to do that. I want to do E-life up. And split to RBO 3.h. There we go. So let's go back here and look at this. So here's our value 3 being loaded here right before entity price drop. So yeah, it's probably 3. So we can copy that entity ID in, and we'll have that one defined now. So now we need equip item drop. Which is just a little bit below, right before entity relic orb, so that looks like B, which is 11. Here it's A, and that's okay, and that's why we have these enums defined for each overlay. It's perfectly reasonable that different overlays are going to have slightly different IDs for these entities. When we define this, we have to, since we don't know the ones preceding it, we do have to define that. And then entity relic orb is the last one, which is down a little bit below, and so we are looking for entity relic orb down below, but we don't see it. Why? We might be in the wrong function. Let's look at the other function. Nope. So this is probably a slight difference in how the way that this is compiled, basically. So we do want I'm a little surprised by this, but that's okay. Offset 28 is where that function is going to be stored. And so if that's being stored in there, then 26, we want to look for things that are being stored in 26. So we have our B was, I think, entity equip item drop. And then A is, looks like relic orb. And let's just check in here to see if relic orb is... Oh, I have these backwards. That's why. All right, so now let's try building this again. So I have one more entity interactable. Which is the argument to initialize entity right at the beginning. And so we need to map this address. And that goes into the symbol table. Let me get this name again. Because the symbol table is updated, we need to tell Splat to rebuild this. Rebuild this extract. It looks like I screwed up my symbol table. Forgot the semicolon. And we're still missing a few other things. So these are variables that were defined originally in these assembly files, and they were just given automatic names. And this is one of the difficult things about mapping in the shared data, is we need ways to easily find these symbols. So I have, for example, these are just symbols that are automatically named by Splat. I need to find where this is defined and why who needs to know about it and why. Actually, I'm going to, it might not be what I think it is. So I am going to force a recompile for all of the C files in this overlay. Sometimes that helps. No, there's still a few. So, it's calling this a function. This is just a header. So it's saying, hey, I don't know what func 8019f2 f8 is anymore. And that's because it's not named that anymore. It is named the other one. Well, there's only one function in here. Well, that wasn't expected. Life up only has one function. Oh, so this is actually an additional function that was being called or pulled into this, but should be split separately. So let's load that up. So this is its own thing, and this is a unique function to this overlay. So we need to do another split at 1f2f8, and we don't know what that is yet, so we'll just give it its own name, and extract again. And what this is just doing is rename spacing this into a C file with that particular name. So we don't have this file yet. Let's see why. What happens, and I haven't figured this out yet, what's happening is when we extract what is expected to happen is what is this? That's not the function I wanted. This C file with an include ASM macro gets added, but it shouldn't be using this prefix because the prefix may change depending on what version of the game is being built. Okay, and so we have a few more things to fix. We're gonna look in source, and then we'll look at it's most likely something that's been extracted that needs to be patched up. Okay, so both of these functions are using this value. But we're not providing a mapping for it anymore. RBO3 is. Let me see what undefined reference to. So we don't have an automatic mapping, and that should just happen automatically. I need to find where the undefined symbols are. I would expect this to have shown up here automatically. Oh, it's this. I have references to this elsewhere that I need to fix. Okay, so it was actually very clearly telling me what I needed, and I was just ignoring it. So in RBO3.c, we have to find this reference to 444, which is now this interactable. And then in 1D, or 1.2D, and we failed. So let's look at what the issue is, and we have an offset issue. It looks like we are quite a bit bigger. And this may be, again, I meant to touch. This could be a problem with just needing a clean build. Is it possible that let's try a clean build. It's possible that this isn't a separate file, and I missed something else along the way, which happens. This is a build. It's taking longer and longer. It was 14 seconds. I think it's getting longer than that though. All right, I'm gonna try one more thing. I'm not convinced. Oh yeah. I'm gonna try removing this. It seems a little odd to have a function hanging off the end. Yeah, and it exists. It's something different. So I'll have to figure that out. Sorry, couldn't get a match at the end, but that's okay. So you've been watching Made Up of Wires. We've been decompiling Castlevania Symphony of the Night somewhat successfully, somewhat not successfully. But we always get a little closer. If you want to know more about the Symphony of the Night decompilation project, go to soten.z.dev, where you'll see progress on the overlays that we've been working on. I'll have some other interesting info later this week about ways that data is being extracted and people are finding out more about the game, and resources that we're creating to share some of that information. You can find a link to the GitHub where we're contributing, and you can find a link to Discord as well, where we're chatting about all this. I'll be back tomorrow, and if I find anything with that other function, that seems to be kind of the type of function to sit down and just kind of slowly work through, rather than do it live on the stream, where I can sit and kind of make my own mistakes on my own time. So I'll work on it a little bit and see if I can get a little closer, and then try to come up with something fun for tomorrow. If you enjoyed what you saw, please follow, and if you want to catch old episodes, look at YouTube, Made Up of Wires with dashes between the words. Old episodes are up there as well. Subscribe on YouTube. That's all I have for today, and hope you have a great day, and see you tomorrow.